All right, hey Honors Chemistry. I wanted to provide a little bit more practice and guided practice with how to write and name ionic formula. I'm going to focus on doing formulas that involve polyatomic ions. So this will be a brief video that specifically focuses on using polyatomic ions with regular metals and transition metals. So if I'm given the name and I want the formula, the first step should always be to figure out the symbols and charges of what's given to me. Now I know that calcium is Ca. Nitrate, that doesn't sound like an element. How do I know it doesn't sound like an element? Well, it's got to end in IDE. So the element would be nitride, and that would be N3 minus. But that's not IDE. Remember, the way that we've named compounds is we end it with IDE. This doesn't end in IDE, so this must be something that's not a regular element. So you will have something like this to use, and if I try and find nitrate on here, if I'm looking, oh, there it is. Nitrate is NO3 negative 1. So I'm going to put that down. NO3 negative 1. And if I'm looking at calcium here, if you look on the periodic table, remember, the group numbers tell you the charges for simple elements. So group 1 elements are all positive 1, group 2 elements form positive 2, group 3 positive 3. Well, it looks like calcium falls into group 2, so calcium is going to be positively 2 charged. Okay, now, we have done this a lot, but I want to write a formula that contains calcium and nitrate, and the sum of the charges needs to add up to 0. Okay, well, if I like to use the least common multiple method, and I'm looking for a least common multiple between 2 and 1, because I have positive 2 and negative 1, and I want the least common multiple because I want these charges to be equal but opposite in sign. So I want them to be the same number. Well, the least common multiple between 2 and 1 is 2. Calcium is already at 2 plus. How do I get nitrate to be at 2, meaning negative 2? Well, if nitrate NO3 minus 1 is at 1, I have to multiply that by 2 in order to give me 2 nitrate ions. And now, if I'm just looking at charges here, positive 2 plus negative 2, that equals 0. And remember, recall, we want the sum of the charges to equal 0. Okay? So, I want to write a formula that contains 1 calcium and 2 nitrates. The way that I do that is I'll do Ca. And then remember, if I need more than 1 polyatomic ion, I need to use a parentheses, NO3 on the outside 2. Now, as a quick little trick, and I'm going to show it at the bottom here, I could do the crisscross method, but you have to be careful of the parentheses and charges and whatnot. If I were to do the cheat here of the crisscross method, I take that 2, I bring it down there, I take the 1, I bring it here, I'll need Ca1, NO3 2, and I put parentheses. So this is the cheat crisscross method, where I take the superscripts or the charges and I write them as subscripts. And notice how I do not put the positive and negative sign in as the subscripts. Also, we don't write 1 as a subscript, so this will just become CaNO3 2, like we have. And that is calcium nitrate. Now, what if I wanted to name the compound from the formula? Well, I could begin to name everything in the compound. I don't even need the formula, as you saw, for the name of the compound. But I want to identify things in here. Right now, is this a simple binary compound, or does this contain a polyatomic ion? If you notice, there are 1, 2, 3 symbols. So this must contain a polyatomic ion. contains a polyatomic ion in here. And I think we all know or can recognize what Fe is. If I look on the periodic table, Fe is right here, and that's iron. So Fe is iron, and I'm going to write that for right now. But be careful, because what type of element, and it says it right there on the periodic table, what type of element is iron? It's a transition metal. So recall, what do I have to put in the name of these compounds that contain transition metals? Roman numerals. I have to put the Roman numerals in. So this is a transition metal. So eventually, I will need a Roman numeral. And what does the Roman numeral tell me? The charge. I don't know the charge yet. Let me look at this SO4 business. This is what's left over. If I look at a table of polyatomic ions and I look for SO4, SO4 is right here. SO4 has a -2 charge. That's the sulfate ion. So this is the sulfate ion, and it's SO4 2 negative. So I'm already beginning to get the name of this compound. It's iron sulfate, but I got to figure out what are the parentheses that need to go here. What are the Roman numerals that need to go here? Well, I only need one iron, Fe, for every one sulfate. I have SO4 2 minus and Fe some charge. Well, if this is -2, what plus -2 will give me 0? Well, the only number that could give me that is +2. This must mean that iron in this compound is +2. That must mean that this must be Roman numeral 2. So the name of this will then be iron 2 sulfate. So naming it is a little bit different. You have to identify the names, and again, if you just give me iron sulfate, if it's worth a point, that's half a point already. You need to figure out the charge, and the way that we figure out the charge is we got to figure out what is it combined with? What is the charge of the thing that it's combined with? So for example, if I had FeCl3 here, this is a different compound. I know that this will be called iron chloride, and I need to figure out what will go in the parentheses, what's the Roman numeral. And I know that chloride is Cl-1, and there are 3 of them, right? Because they're Cl. And I know from the periodic table, if I look on the periodic table, chlorine is here. Chloride will form a -1 charge. If there's 3 of them, that means that all 3 of them give me -3. What plus -3 gives me 0? That will be +3. And that means this iron will be positively 3 charged. That's different than this one. These are 2 different irons. And if I want to name this one, I'd have to do iron 3 chloride. So notice how I have to figure out the Roman numeral. I have to first figure out the charge of the other anion or the other ion in the compound, and then figure out what must the charge of the metal be that when I add it to the negative charge, I get 0. So to quickly recap here, I can name the metal and the polyatomic ion, or the metal and the non-metal. And then to figure out the Roman numeral, I have to figure out the charge of that transition metal by looking at the charge of the thing that it's combined with. Alright, so I hope this video was helpful. This was a video on polyatomic ions with simple metals and transition metals.